Service friends, I'm Orpheus Praxis. Welcome to my channel. May this listening bring you clarity and peace.
Okay, so have you ever just stopped and wondered, what's the total electric charge of, well, everything, the entire universe?
Yeah, it's one of those huge questions, isn't it?
It really is. And today we're doing a deep dive into some really fascinating sources. They suggest a cosmic reality that's quite different from the usual picture.
That's right. And it all kind of hinges on a basic physics law.
Exactly.
Our mission, really, is to see how something fundamental like Gauss's theorem can actually, probe the universe's real shape. We'll be looking closely at this model called the Fractal S3 reality, FS3R for short.
FS3R. Okay.
Yeah, the core idea is that maybe the cosmos isn't infinite and flat, but a compact fractal sphere.
Wow. Okay. So our goal for you listening is to kind of get your head around how this concept, this FS3R, might solve some big cosmic mysteries.
And maybe offer some, surprising insights into space itself.
My mind is already slightly bent just thinking about it. Okay, let's unpack this. So Gauss's theorem first. Remind us. Basically, it says the total electric the flux out of a closed surface. It's tied to the charge inside.
Precisely. The amount of charge inside determines the total flux passing through the surface. Simple idea, profound consequences.
Right. Now, here's the kicker. What if that surface is the whole universe? For that total flux to be, finite, a sensible number, not infinity, which you'd kind of expect from a fundamental law.
Then the universe itself has to be compact and needs to have a finite volume.
Okay, so not infinite.
Exactly. And that's a direct challenge to the standard model, the ΛCDM model, which generally treats the universe as spatially flat and, potentially infinite.
So an infinite universe, under Gauss's theorem, gives you infinite flux.
It leads to inconsistencies, yeah. Infinite global electric flux doesn't really work. But here's something else. In a compact universe, for Gauss's theorem to hold perfectly, the total electric charge must add up to zero. Exactly zero.
The whole universe, electrically neutral.
Globally neutral, yes.
Yeah.
It's a pretty strong constraint, and this is where the FS3R model really offers an elegant path forward.
Okay, so let's get into the FS3R model then. It meets that compact requirement. You said it's a sphere.
A compact three-dimensional sphere, yes, but not just a simple sphere, it's fractal. Imagine it having layers or shells within shells.
Okay, like nested dolls.
Sort of, yeah. But these layers are self-similar, meaning they look alike at different scales, and they're scaled by a specific number.
Which is?
The golden ratio, Faye. About 1.6118.
The golden ratio.
Oh.
Seriously, that pops up everywhere.
It does, and the motivation here comes from something called scale relativity, this idea that maybe physical laws aren't fixed, but depend on the scale you're looking at.
So this fractal structure, scaled by phi, that's very different from the usual picture of a smooth, homogeneous universe, right?
Absolutely. It implies the universe has this intricate built-in structure right up to the largest scales.
But does this fractal idea actually match what we, see out there?
Well, surprisingly, there's some alignment. Look at the Sloan Digital Sky Survey. Huge galaxy maps, up to about 100 megaparsecs, which is, over 300 million light years. Galaxies seem to be distributed with a fractal dimension of about 2.2.
2.2, not 3.
Not 3, which would be uniformly filling space. 2.2 suggests a clumpy fractal pattern on those scales. Beyond that, it does look more homogeneous, smoother.
Okay, so the universe is fractal up to a certain point, then smooths out.
That's what the data suggests. And the FS3R model, combined with Gauss's theorem, naturally gives you that finite flux and zero total charge we talked about.
Which the standard infinite model struggles with.
Right. And the FS3R model even makes predictions. For that d equals 2.2, it tells you how flux and charge should scale down through those golden ratio shells. It gets quite specific. It says the total flux ends up being about 1.531 times the initial flux, and charge scales down by phi to the power of minus nd.
That's pretty detailed. And you mentioned other observations. What about the cosmic microwave background, the CMB?
Yeah, the leftover heat from the Big Bang. Data from the Planck satellite gives it what's called a box counting dimension, another way to measure fractality of about 1.85.
Again, not 3, something structured.
Exactly. And also how galaxies cluster. At smaller scales, say less than 30 megaparsecs, the way they group together follows a mathematical rule, a power law, that also fits with that d equals 2.2 fractal dimension.
So multiple lines of evidence seem to point towards, fractals.
They seem to hint at it, yeah. Patterns that the FS3R model predicts more naturally than the standard model sometimes does.
It sounds quite elegant, this FS3R model.
Mm.
If it solves the charge neutrality issue and fits observations, what's the main resistance? Why isn't it more mainstream?
Well, it's a big shift in thinking. The idea of infinity is pretty deeply ingrained in cosmology, challenging that and proposing this specific fractal structure based on the golden ratio. It's a lot to take in. It requires rethinking foundational assumptions.
A paradigm shift, basically.
Pretty much. But the advantage is clear. The FS3R framework provides that global charge neutrality and a finite calculable electric flux naturally. ΛCDM needs extra assumptions or just sort of ignores the problem.
So FS3R suggests the clumpiness we see isn't just random, but maybe part of a fundamental fractal pattern.
That's the core suggestion, yes, that the large-scale structure might be inherently fractal. It offers a potentially more, well, elegant explanation.
So for you listening, what's the takeaway? I think it's a really powerful example of how applying a basic law, like Gauss's theorem, can lead to some truly mind-bending insights about the cosmos.
Absolutely. It forces us to question assumptions we might not even know we had.
And it leaves you wondering if this fractal pattern, scaled by the golden ratio, is real. What other hidden symmetries or patterns might be lurking in the universe's depths?
What else are we missing just because we assume smoothness or infinity?
Something to definitely chew on, a fascinating possibility hidden within the laws of physics.
Thank you to everyone who stays with us, who listens, thinks, asks questions, and helps the project grow. May the merit accumulated from listening and reflection bring benefit to all living beings and help make the world a little more peaceful. Subscribe to walk this path together with us. I am Orpheus Praxis, wishing you all clarity. Namaste.